Hi folks, so data handling question from the 2009 paper, question 5. Right, we are looking this time at owls. You're told they're territorial and they prey on several species of small mammal. And you're looking at 3 pairs of owls over a 2-year period. And then we've got the first, so it's not actually a lot of context, you're literally given just 2 lines. But you have 3 owl pairs and what they all eat. This is a monster graph, so you're going to have to be careful that you understand what's going on here. So we've actually got 2 graphs in one, because here's one set of axes almost, and here's a second one. Totally different scales, but the whole point is that they are up for the same times. So here's autumn, winter, spring and summer for year 1, autumn, winter, spring and summer of year 2. So what you've got here is about 2 different species, deer mice and wood rats. Okay, the deer mice are the dotted line bits and the wood rats are the solid. We've got the average number per hectare, so how many of them were found in a particular area. And then we've got how much it weighed in a particular area. So in autumn, say, year 1, you went and found all of the wood rats that you could find. And if you weighed all the wood rats that were in 1 hectare, this is how much they weighed in total. It's a fairly complicated graph. But as long as you don't panic, it's okay. Right, what percentage of the total number of prey eaten by owl pair A were deer mice? Okay, so here is our data. Just owl pair A and how many of these basically percentage-wise. So percentage is your number, what you got, divided by what you could have got, so the total number there. So the total number, grab calculator, what we've got, 484 plus 29 plus 15 plus 22, 550. You know it's going to be a pretty massive number when you do this, because 484 out of 550 is quite high. And sure enough, 88%. Okay, simplest whole number ratio. So we have owl pair B this time, so I'm looking at this data, and in particular we're looking at deer mice, brush mice and rock squirrels. These are not nice numbers, 528, 114 and 24. So for a start, there's going to definitely be some cancelling because they're all even, so at least you know you can divide by 2. But I'm going to try first to divide everything by 24 because that's my smallest number, and if it works then that becomes a 1. Just on 114 divided by 24, 4.75, that doesn't work. So I'm going to try it by 12. So I'm going to do 114 divided by 12, 9.5, no. So I'm going to try it by 6. Right, that works. 114 does, that gives me 19, and this would be 528 divided by 6. That works as well, that gives me 88, and 24 divided by 6 is obviously 4. So this is my best, simplest whole number ratio I'm going to get. You could have just done it as divide by 2, divide by 2, divide by 2. Doesn't matter how many lines you use to get it, as long as you get to the simplest whole number ratio. Okay, using evidence from the table to identify the owl pair that foraged in a different habitat to the other 2. Here are our owls again. So you're trying to find out if there's a different pattern of what they're feeding on. Even glancing at it, I think you can see this quite easily. These ones are not very different really, number-wise, and this is not really different massively. But look at this one here. Owl B and C pairs, they have pretty similar proportions of wood rat and brush mice. A, on the other hand, looks totally different. So A is definitely the one that feeds somewhere differently, because the wood rat and the brush mice are so different in comparison to B and C, which are quite similar. Okay, values from the graph to describe the change in average number of wood rats per hectare from spring of year 1 until spring of year 2. So values from the graph, this is a describe one. So we're looking for, where are we going? We want wood rats per hectare, so it's this number that I'm reading off, and we are going year 1, spring, till spring of year 2. Okay, so we've got this point. I'm going to then increase to this point, and then it decreases to here and increases to here. It's another 4 points. That's pretty much the standard you're looking at for getting those 2 marks in a description question. Okay, so we've got our starting points. I'm just going to pull off the data, and then you would put this into a kind of sentence structure that makes sense. Okay, so it's not the neatest or the easiest thing to read off, but these are going up in 0.2s, so that would be 3.6. So it's 3.6 in spring, year 1, and then it goes up to 4 in summer, so it increases, and then it decreases, so that goes down to 2 in winter, this is year 2, and then increases again to, that's a little bit tricky to read off in this direction, so I'm actually going to go this way so I can read it, and that's going to be 1, 2, 3, 4 down, so yeah, 3.2 in spring of year 2. So you would need to put that all together in a nice description. Although I'm giving you the data points, one of the other ones they will accept, you'll see it on the SQA marking instruction, they would accept you saying it starts at 3.6 and then increases by 0.4. So you could say it goes up by 0.4 in the spring, from the spring to the summer. I think it's a bit better just to put the data in, because otherwise you're doing a calculation on top of that as well, and if you get the calculation wrong, you're going to lose the mark. Okay. Right, percentage decrease. You just don't get normal simple percentages that often anymore. It is always, well, not always, but very, very commonly, it's all about percentage change. So change divided by start times by 100. That's what we're looking for. Our change here, total average total biomass in the woodrats. So I am looking again at the solid line, but this time I'm down here between the summer of year 1. Solid line summer of year 1 is here, and the winter of year 2. Okay, so it starts at 250. Okay, so I need my change, so 250, take away, what have I got here? 120. So 130. So 130 over 250, and then multiply by 100, gives you 52%. So just dropping my pen. Oh, and it won't let me stop. Okay, question D. Calculate the average mass of one deer mouse in summer of year 1. Okay, this is quite a weird question, because you look at this and go, well, there's nothing about one deer mouse, but actually it's about looking at the graph quite carefully. So summer of year 1, just trying to get my pen back up. So summer of year 1 is down here, okay? And what we have is the number, now this is, remember we're looking at deer mice this time, so the number of deer mice I have. So I have, on average, trying to count this up, 0.2, 0.4, 0.6, 0.8 and 1. So on average I have 11 per hectare. And what I also have is the information that says, reading very carefully from the right place, that the average mass in total in that hectare was 220 grams per hectare. So now you just have to say, well, okay, how much must each deer mouse have weighed? If the total mass was 220, just divide that by 11 and you get that each mouse weighed 20 grams. I think it's a tricky enough question. Okay, the size of the territory of a pair of Mexican spotted owls is different in winter and summer. This is a statement they're giving you. Give an explanation of this observation which can be supported by evidence from the graph. Here is our graph. So they're saying, why would you have a different size of territory in the winter and in the summer? Well, here is my winter information. suppose up to here. And here is my summer. Here is winter again. Here is summer. I think there is quite an obvious difference between them. In the winter, there is less kind of food around than there is in the summer. So if you are a hunting animal, you're going to have to cover more ground in the winter to pick up the same amount of food. And that's what you have to explain. Here is your SQA Mark Scheme. Look at it carefully, make sure that you're happy that you would have got all the marks, and that's it.